Alrighty, it's installment number 3 on chapter 6, time value of money. It's taking time to explain this chapter. Bad joke. Okay, well, what do you want for a spring break week? We want to talk about other issues with time value of money, different types of time value of money. Before we talked about simple single sums. How much do I need today to invest to have an amount 20 years from now? How much do I need to, what would I have 20 years from now if I invest a certain amount? We are in the present category, we're going to talk about annuities. Prior to this, again, just to illustrate prior to this what we were doing, we were looking at the following factors: present value, how much do we have today, or how much do we need today? Future value, how much will we have in the future, or how much do we need in the future? The interest rate, and the number of periods. These factors were all we were concerned about, and if we knew any three, because of the way formulas work in algebra, and that's about as far as I go. I say the word algebra, I say the word calculus, I say the word trigonometry, but I don't go any further than that. I just turn to a calculator or a computer after that. But if we know any three of these, and we have a financial calculator or a table, as we did in the old-fashioned days, we can solve for the unknown. That's a pretty powerful tool to use in ways that we haven't even talked about for simple single sums, because we can say we know what our present value is, we know what our future value is supposed to be, we even know how long it's going to take us to get there, but we can solve for, well, what interest rate do we need to get to make all that work out? That's one powerful tool. The other tool could be the following, that we know the present value, we know the future value that we want, and we know the interest rate that we can get. Now we can solve for how long will it take to happen. How long will it take? So those are the important things of what we've been doing so far. Now we're going to add a new concept to these four variables of an equation. We're going to add one new factor, and that is what's going to be labeled, particularly most likely on your financial calculators, as payment. What if we make a series of payments over a period of time, given a certain present value, a future value, an interest rate, and a number of periods, or years, or months, or quarters? What if we have all that known to us, but it's not just a single sum, it's not a simple sum, but it's payments over time? What will it yield in future value, or what payment do we need to match and meet our goals here? Let's say it's going to be an equation with 5 factors. It's going to be an equation with this factor, the present value, the future value, the interest, the number of periods, and a series of payments. And this equation will allow us, if we know any 4, to solve for the 5th one. It's powerful information. You could use this in the following way, just to give you an illustration. And this is how we do it almost on a routine basis with clients in financial planning situations. They say, I want to buy a house. I'm going to get a mortgage. How much can I afford to get a mortgage? So we can solve for the how much, but if we know how much payment they can make, if we know what the interest rate is, that's here. If we know how long the mortgage will be, and if we know we don't even need to know the future value. The equation actually will work with only either one of these two. So if we know the amount of payments, the interest rate, and the period, then we can solve for the present value of how much we will be able to borrow. That's the present value, and that's the mortgage amount, and we can tell the person how much the mortgage is going to be. So the actual equation here can be an equation where we know the following. We know the present value, we know the interest rate, we know the period of time, and we know the payment. And we can solve, if we know any 3 of these, we can solve for the other one. So to illustrate what I just described is, a person says, how much can I borrow? And we say, well, how much can you afford to pay per month? So we know the payment amount, we know how long we can get a mortgage for, we know what interest rates are going to be, And when we solve for the present value, that tells them how much mortgage they can get today, because that's what the present value means. Sometimes people ask the following question. They say, sometimes they ask the following question. They say, I need to buy a house. I'm going to need a mortgage of X amount of dollars. So now we know the mortgage amount. We know the present value. We know what the interest rates are going to be at the banks. We know how long they'll lend money. And then we can solve for the payment amount, and we can say to them, well, can you afford to make this payment? If they say yes, then they can buy the house. Or at least they can afford to buy the house because they can make the payment. This is where annuities come into play, where there's a series of payments of equal amounts. That's what loans of mortgages and car loans are all about, where there's a constant, steady state of payments, steady in the amount. That's what annuities are. So we're going to do some calculations with annuities. There's one of the great slides of the world, and that's what an annuity looks like under an electron microscope. All right, there are two types that the intermediate accounting textbooks teach you about when it comes to annuities. There's the ordinary annuity, which is where the payment, to use the initials, comes at the end of the period. End of the period. So if it's monthly, it's the end of the month. If it's annually, it's the end of the year. The payment comes at the end of the period. That's an ordinary annuity, which is opposed to, and this slide was used on my most recent eyeglass examination where I had my eyes tested. This is what it looked like to me using my current glasses. That's why I can't recognize you in class. This is what you all look like. You look like annuities do. An annuity due is the payment is made not at the end, but at the beginning of the period. And it makes a difference in the calculations, whether you're paying at the beginning or the end of the period, again, because of the time value of money. If I pay at the end of the month, it should cost me a little more because interest has been running for the whole month. If I pay at the beginning of the month, there's a little less interest because I've paid earlier. And vice versa, depending on what side of the fence you're on, the lender side or the borrower side. But so the concept works either way. Let's talk about the future value of an annuity, because when we went to that equation where we said we have, for the mortgage, we had 4 factors and we could solve for any one: the payment amount, the number of periods, the interest, and the present value. We could solve for any one of the 4. We could also do an equation where we have the payment amount, number of periods, the interest rate, and we can solve for what the future value will be. And the cool thing here is, since it is an equation, just like it was here, if we know any one of these 4 in this side, over here, we can solve for the missing ingredient. So we might say, well, we know what we want to have at the end of a certain number of years, so we know the number of years, and we know what the interest rate is we can get, so these are all known. And then we can solve for what payment we need to make in order to reach a future goal. So the annuity equations come in 2 varieties, a present value variety and a future value. Future value of an annuity. Future value of an ordinary annuity. So we're going to have to do each one of these future value and present value in 2 styles. An ordinary, and the other one was the annuity due. So we'll be doing that one. So that's number 1. And number 2, which we'll get to, is the annuity due. So remember the 2 different varieties. What we'll be able to do, however, is only need 2 tables, a future value table and a present value table, and we can figure out how to do the annuity due with just a slight manipulation of the tables. So let's get I'll tell you what we're going to do. We're going to stop here in order to keep these things short, and we'll pick up with this example on the next time.